The early humans discovered fire by rubbing two stones against each other. You must have also felt that your hands feel warm when you rub them together for a few seconds. Do you know the reason behind these phenomena? When two stones or palms are rubbed against each other, the motion of the stones or palms is resisted by some invisible factor that is responsible for producing heat. In both cases, heat is produced due to the force of friction that acts between the two surfaces in contact. Whenever two objects try to move or actually move over each other, a force of friction comes into action that tends to oppose the relative motion of one object over the other. Is the amount friction the same for all surfaces? No, it is not. Whether the friction between two surfaces will be small or large depends on the roughness of the two surfaces in contact. A smooth surface offers less friction, whereas an irregular surface offers more friction. To understand this better, let us perform a simple activity. The materials required for this activity are a spring balance, a brick, a metallic string, a piece of polythene. Tie the metallic string around the brick and connect the hook of the spring balance to it. Now hold the other end of the spring balance and pull it towards yourself. As soon as the brick starts to move, check the reading in the spring balance and note it down. It gives you a measure of the force of friction between the surface of the brick and the floor. Now, wrap the polythene around the brick and again tie a string around it. Connect the spring balance to the string and pull the brick. Again, note down the reading on the spring balance as soon as the brick starts to move. What do you observe? You will observe that the force of friction is less this time. This is because the surface of the polythene is very smooth as compared to the irregular surface of the brick. Let us perform another activity to have more clarity about the variation of friction based on the nature of the surface. The materials required for this activity are a wooden wedge, a toy car, a towel, and sand. Place the wooden wedge on a smooth floor. From the top of the wooden wedge, allow the toy car to slide down. You will observe that after covering some distance on the floor, the toy car stops. Note down the distance covered by the toy car on the floor. Now, spread the towel uniformly over the floor, ensuring that there are no wrinkles. Again, from the top of the wooden wedge, allow the toy car to slide down. As it stops, note down the distance covered by it over the towel. Now remove the towel from the floor and spread a thin layer of sand uniformly over the floor. Again, allow the car to slide down from the top of the wooden wedge. As it stops, note down the distance covered by it on the sandy floor. Compare all the three distances covered by the toy car before it comes to rest. You will observe that the toy car has covered the maximum distance on the smooth floor and the minimum distance on the sandy floor. Do you know why this occurs? This is because irregularities are minimum on the surface of the smooth floor and maximum on the surface of the sandy floor. These irregularities are responsible for the increase in frictional force. Even those surfaces which appear very smooth have a large number of minute irregularities on them that obstruct the motion of an object. The friction acting on an object also depends on the weight of the object. It is difficult to move a heavier object on a floor as compared to a lighter object, as the heavier object experiences more friction as compared to the lighter object. Do you know why? This is because interlocking between the irregularities of the two surfaces in contact is more in the case of the heavier object as compared to the lighter object. Thus, heavier objects offer more friction compared to lighter objects. Let us now recapitulate the concept studied.